and let's move on with today's session. And the way it has been planned is I'll try to explain how a data science problem is approached. Okay. So let me know once you can see this approaching a data science problem. Hope this is visible, my screen. Again,
it is visible.
Yeah.
Visible.
Yeah, now it's okay. So I'll start with this. The problem, I'll try to explain how a data science problem is formulated, how it is addressed, and then what are different steps. And we'll go, I'll completely understand that this 1 hour session may not be sufficient enough for you guys to understand everything, because it's going to be technical heavy, it's going to be code heavy, but I'll try to go slow. Don't be impatient if you're not getting everything, because it happens with everyone. In fact, I myself may not be aware of many things which are nitty-gritties of these things. So it's completely normal if you're not getting an entire everything. Okay. So moving on. So what is a data science workflow? Actually, how it happens, and what are different components of it. So first of all, we always start with defining a problem or defining a goal. We must be very clear at the very beginning, what is my goal, what are my problem statements, and what we are going to do with it. It's completely okay that to revisit those goals, but we need to have a starting set of the goals. Those parameters need to be very clear that this is what we are going to solve. If we are unclear with the problem statement, our starting journey is itself flawed. So it's always, first of all, we need to have a very clear goal. Then the second point is, we are all data science guys all working on the statistics on different aspects. So we are going to work with data. We must have a lot of data. We must have data, or at least relevant data according to what is our goal is. So get the data as a second aspect. Then once data is there, most of the data that is residing out there in the world, it is very chaotic, very unclear, with lot of noise. So we all, as a data scientist, spend significant amount of time in cleaning up the data. Once data is clean, we go for enrichment of the data. By enrichment, I mean to say, some say that cleaning and enrichment can be one part. Okay, cleaning and enrichment can be, they all come under data pre-processing steps. Means we pre-process data to bring it into a shape that can be processed by our modeling algorithms. Once that is there, we also need to be very familiar with the data. We need to understand what our data is speaking to us. Our data we must keep on playing just with the data till data starts speaking to us. And how will it happen? By understanding, by visualizing, by raising so many questions that can be raised on the data, by seeing the same data in different angles. And the next part is where it has been as deploying machine learning or something. It is more of modeling, and these modeling algorithms comes from both the worlds: statistics, machine learning, data mining. So we as a computer persons, we as an AI solution architect, we as a in the industry, we see them as a broad category that is called as modeling algorithm. And then we iterate. Of course, it is never going to be, you are not going to get very good results for the first time. If it is happening, you are going to be one of the luckiest person who is working in data science. Most of the time, it is going to be iterative process. Okay, so moving on. So this is a scenario. I'm going to, since we said that we are going to see how a problem is approached here. So I've taken a small scenario. A movie production company, they, before starting on the next movie production, they just want to do a thinking and brainstorming session based on the data, of course, that of which movie we should do the production. Like, will it be an action movie? Will it be a family movie? Will it be a science thriller, or will it be a horror movie? What kind of movie? And for that, they have kind of formulated certain questions, and these formulated certain questions, and these are the few questions that we will try to address. How we can extract these. Okay. So So in this case, we are going to make use of IMDb website for the historical information, for the historical movie information. And let's look at the data first, from where we are going to be extracting the entire data. So this is IMDb website. And this page, this particular URL gives 50 movies in one single page. Okay, there are top 50 movies for year 2017. Similarly, as we change 2000 instead of 2017 in the URL, if we give 2018, it will bring it 2018 movies. It will bring 2019 movies, depending on the year it is written in the URL. And this is how a URL computer website URL is constructed. There are different components. So after title, there is release date. Release date is nothing but year. This is how IMDb's website is constructed in there. So we are going to analyze 18 years of movie after 2010 till 2018 and see and try to discover what are the different trends that can be extracted from this information. Okay, I'll come back to this page once more, but before that I'll move on. So now our first goal is we must have our first problem was to have a goal. Now we have that. We have a problem statement. We have task in hand, and the task is we are going and the source of data as well. We know that our source of data is from IMDb website, and from 2000 to 2018 we are going to extract that data. So that extraction is going to be part of our collection of the data part. Okay, and this is the information that we have kind of like zeroed on, that this is what we're going to make use of. Okay. So this is the information that we are going to extract in all, the information that name of the movie, rating of the movie, Metacritic score. So okay, let me go back to the page again. Yeah. So these are the information that we are going to extract: the name of the movie, the rating of the movie. This is Metascore. Metascore is a parallel website which gives another view of scoring. So this we don't need to be aware of all this. As a data scientist, we must know how to play with the data, even though the data is not making sense at first. Okay, so we are going to extract number of votes. We are going to extract what is the gross business that this movie did. So these are the information that we are going to extract. And I'm not sure, maybe this is going to be really interesting for you, how to get that extract like something. Have you ever done, this is Chrome browser, have you ever done a right click and there is an inspect thing? Can you, once you do that, you get the entire, there is a lot of manjo jumbo written in there, but in there, since we have clicked on the Logan, that's the name of the movie, right clicked on that, and we can see that Logan is there. And this is the information that we are going to extract programmatically with the help of Python code with some of the libraries which are going to be there. And this will demonstrate how powerful Python is. I'm not saying that other languages do not have this. Most of the languages have these kind of capabilities, but the difference is how easy things are being made by Python for different aspects. So since I'm focusing on Python because that is what the context is. So we get that Logan, and the construct of Logan is like this. Means we'll have to identify a pattern or the tag, especially that it is within the span class, and the span class goes by name this, and a the tag. Okay. Before that, let me show you how a basic HTML page is. Yeah. So since we are going to work with a web page, this can be a very new thing for most, but this is how a basic web page is designed. Whatever any website that you visit, it is based on HTML page. There can be different variants, but this is for basic HTML structure, that these pages are designed in form of tags. There are different tags like HTML, head. This is going to be in every website page, and title, head, body, H1P. What does that mean? Even I am not aware of, and that we don't need to also. So that's why I'm focusing on by right-clicking and showing what exactly pattern that we are looking at. We are looking at this Logan title, which is embedded inside of a tag and span. And let's see how we can reach it, even though we are not at all aware of how HTML is basically designed. Believe me, I'm also not an HTML guy. I'm not a web person. So this is as a Chinese for you as for me. Okay. So now these are the components we are going to make use of to make the data collection happen. There is a library goes by the name requests, which can hit a URL. You give a URL and it will hit and bring the web page down for you. And another library which is called Beautiful Soup, and this is a parsing library. Means it will help you read the content which is not going to be simple English. It will have a certain structure because that is what HTML and XML files have. But what structure, how they are structured, we may not be aware of, and we need not know. Only we need to focus on what exactly we are trying to extract from that. Okay, and RA is a regular expression library. Most even R has that, and Pickle is another library which can help save immediate outputs and load them. So once we have done most of our job, it is good to save. As we keep on saving our Word file and Excel files, it is good to save our intermediate outputs, which we feel that which has reached a significant level of significance. Okay, and this is I guess by now you must be aware of this is the way how we can now import different libraries. Not spending time on that. So want to take a pause here and just want to know if I'm going fast or I'm going at right pace, or can someone, or okay, let me see the chat. Okay. Okay, thank you. A little slow, thank you. Then that makes me easier, way easier. Okay, now so we are going at preparing of the data. Now we have identified a URL that we are going to extract. We are going to make a request to the URL, and that once we are hitting that URL, it will bring the entire web page down to my system. So we gave URL as a variable that I have created here by the entire URL that we have just visited on the IMDb website, and this is how different variables are created and initialized in this. Okay. So these are the 3 steps: list of the URL, makes a request to the URL, and read the content of the request and convert it to a beautiful soup object. What does that mean? Beautiful soup object. Beautiful soup is a library, and once we have beautiful soup, it means we'll pass into the beautiful soup content. Now it has been, since it is a very good parser, and it helps us read the contents in a proper way. It will present these contents in a nicely structured way, which could have been very mumble jumbled if this would have not been used. Plus, it gives us other capabilities as well, which you'll see. Okay, so now exactly what we are going to extract, we'll go slowly. So this is actually how HTML content is going to be constructed. There is a division class, and most of the content is always present in division class. And these are H3P, division P class, and these are sort of tags. And how we can access that tags with the help of Beautiful Soup, we'll see now. Okay, so this is how we are going to get entire content for us. So right now, all the movies from that URL is been stored in movie divisions. Now from this movie divisions, I'm going to get first movie. Whatever was there on this page, I'm going to extract that first movie in the variable in movie, and we'll see how that looks like. Okay, and this is looking so pretty because it has been because Beautiful Soup has prettified it. Okay, means Beautiful Soup has followed a certain patterns which are inherent in this tags and XML files and all, and they have this. So we don't need to be aware of all this, but only thing is it is in a much more readable format had it been a simple notepad or a WordPad. Okay, so now our point of interest is getting the name of the movie here. So this is the name of the movie, and how we can access it. See, within the division there is H3, and within the H3 there is a tag. So these are tags. Whatever is placed within this greater than less than sign, these are called tags in HTML. So these are the tags. Okay. Similarly, we want to have extract what is the runtime. So we have a span class with the name runtime, and where there it is written runtime. And all the structure is going to be in the same format. So if we are able to extract all this information for one movie, we can simply loop it to the entire content and we can extract everything. So we'll slowly build on one movie and then loop it, and that will be a quick thing. Okay, so this is how we are going to extract our first name, that is called domain. Okay, so movie was the name of the variable, S3 was the first tag, and then it was within the A tag. So this is how we have accessed it. So this is the structure which you can see at the upper part of the screen. Within the S3 class, this is A. So see, even without knowing how that is entire HTML is constructed or with that, but we can still extract the movie as we are focusing only on that. And how we can get that? It is pretty easy to reach what tag it is going to be by right clicking and doing an inspect. Similarly, if you want to have that inspect on, say, suppose I close this, right click and do an inspect on rating, it will open a page where rating is going to be there. See 8.1. So for this, we are going to see, we are seeing that strong tag is there. We are going to make use of strong tag to do that. So it is so easy. Like Beautiful Soup is a movie is a Beautiful Soup object. Movie S3 is the tag .a, and you can simply as you traverse a tree, this and then that you can reach to the movie name. Okay. So we have extracted a movie name from here. Similarly, we are going to extract other components as well. For example, rating, we are going to make use of strong. And again, it's going to be the same thing. Find is a command which can find the entire, find within that entire content. Finds is strong, and since the strong is going to be unique in the entire thing, only that thing works for us. Moving on. So this similar way is to extract Metacritic score. Instead, Metacritic score is within the span class, and this is the unique thing that identifies for us that where Metacritic score is going to be there, 77, and that is how it has been extracted. I'm not. It's going to spend time on this. If you want, if you have questions like how it is happening, everything, open Beautiful Soup on your computer system. See a documentation. They have very nice documentation. You can open it, read it, and it is kind of going to be very clear how everything is working here. But just to let you know, there is nothing more than moving step by step here, moving between the tags with the help of find command, moving.find function, and within that find function, you are going to focusing on, okay, now right now data value, that is what we are extracting. That is number of votes is going to be there. Moving on, runtime. Again, now it is within the span class runtime. So we extract, we will do a find on the span class, look for runtime, and that's there. That we get runtime. Moving on. Similarly, we are extracting genre now, like which is it going to be action, drama, science fiction, or whatever it is going to be. The genre. As again, it's going to be span is a tag. Within the span tag, we are looking for genre. So find span, within that span, we are looking for genre class, and it will give us what class of this is. Moving on, and now little bit interesting thing, like what if two tags are pretty similar? How are you going to identify them then? For example, in case of these two, this gross value, gross collection, and the number of votes, they are going to have the same properties. They are within a span data value, data value. They are on the same data values. Still, we are going to make. So we have to find something that is very unique for that particular extraction, and which is gross. So we are going to find gross, and if it's a gross tag, this means this is going to be a gross amount of collection that movie has done till now. Okay. So we have to focus on how uniquely we can identify the pattern that we are looking at within that. So now we have extracted different components one by one, and our work is now going to be combine everything and see how everything can be extracted into one code. So these are the things that we have extracted till now, and this code is going to extract this has nothing. We have done certain initializations. Don't go into the complexity of the code. It will overwhelm you because this code is not something that you can start writing on day one. But this code shows you the capability of Python and how powerful it is. Run this code and it will bring the entire content, means from 2000 to 2018, the way we have extracted one by one. It will loop it and give you entire content in different lists. All the movie names will come into this, all the movie ratings will come into this, which are right now initialized on the upper part. All the Metacritic score will come into another list, all the votes will come into another list. So list is a data structure from Word of Python. Okay, so this shows the power of Python. Like so this particular program, maybe say 25 lines of code, gives you the entire information, and you'll see how much information it has extracted. And to see that information, how much it has been extracted, we are going to make use of another library that's called Pandas. And Pandas help us arrange everything in rows and tables so that it becomes very easily visible to us. Just like in Excel sheet, we can see everything in rows and columns. So this will help us arrange data in a way that that is easily identifiable, viewable by us. Okay, so this is how a data frame is getting created. Import Pandas as PD. This is importing the library that we are going to make use of, and these are the variables that we have created up here. Movie name, movie rating, movie Metacritic. So these are now going to be combined to form one single table. So movie name is now going to be named as name. So this is how we are going to create the movie. All the genre is going to be named as genre. Rating, movie rating is going to be named as rating. These are the column names that we are giving there, and data will be populated from those lists, which has already been populated by previous code. Okay, so now once that is done, I have created this. Now we have raised a significant point of significance where we want to save the data frame which has been created, and for that we are going to make use of another library which we have imported at the very beginning called pickle. So we are going to save that. This is how we are dumping the file into my into the directory where it is, where the entire operation is happening. And once it is dumped, now I'm going to upload it again. We can continue working on that without even uploading, but this is how it is being done here. We are uploading the file. So now is the time we are going to look how our data frame is. So this is how our data frame currently looks like. Data frame is nothing but our table, how our table looks like. So it has name, it has genre, it has rating, it has runtime, Metacritic score, votes, and cross. All the information that we thought of extracting at the very beginning has been extracted and put in this table in a nice format. Okay, but it still has few things that needs to be worked on. For example, see in genre column, there is a \n, which is kind of a new line character in computer. So that is being appended everywhere on the in genre. So this is kind of a noise or a junk character which we would like to remove. Plus, every genre has more than one category, action, adventure, because a movie can be categorized in more than one category. So we are going to make use of only the first category, which is sort of major one. Like this, if we have to categorize in only to one form, it is going to be the one genre. So for like Gladiator is going to be action movie, Memento is going to be mystery movie, Snatch is going to be comedy movie, and we are going to remove other tags. Okay. Similarly, in runtime, if you are going to work, so you know how we work in Excel sheet. If it is going to be an integer, if you want to sum it, if you want to multiply it, and we have say minute in there, min in there, or a string in there, those operations cannot be done. So we would like to clean that up as well. So now we are moving into the second phase. Our collection phase is done. Now we are moving into the second phase of the data science operation, where we are trying to clean up our data so that it comes in a format that can be played by us, that can be used by us for further operations, for visualization, for maybe simple additions, simply mean, for calculating mean, median. So these kind of operations can be done only when our table, our data is in a format like integer or float. If it is kind of mixed one, like 155 minutes, those operations are not going to perform. So that is what we are doing. Plus, you can see the second one as no Metacritic score. Snatch. Movie Snatch is not having Metacritic score at all. So we would not, we are not going to make use of. We'll simply drop them off. We'll remove it. Okay. We may not need. We are going to make use of only those rows which have complete information. And similarly, in the gross section, their dollar sign is appended, and at the last it is million. M is for million. So M is also appended. So we would like to strip them off as well. So these are the few things we are going to work upon now. That is in the cleanup. And plus, this is how our different columns are looks like right now. Name, gender. Name is not a string, or rather, runtime is not a numeric or an integer number right now. Metacritic is also not numeric or integer number right now. So we would like to have those in those particular formats so that all the operations that we want to do can be done on. So exactly this how it should look like. This is how we would like to see our data frame too. So this is our goal now. We have our entire data that we wanted to work upon. Now we have a goal that this is how our data should look like. So this transformation is what we are going to do in next 10 minutes or so. Okay. So see here, rating, runtime, or a float 64 is floating point or integer or numbers. You can say that these are numbers. Votes are going to be non-decimal, so they are integers. Cross, rating, runtime, they can be fractional numbers, so they are floats. Name and gender, they are strings, so they can be objects. Okay. So this is our goal now. Moving on. So this is our data cleaning step. Okay. So we start with having a look like how many rows are there which have at least one null or none or incomplete information. See that for out of okay, let me go back a little. We see that there are 4,422 entries that have been downloaded. Means we have information for 4,422 movies. Okay, so now we can see that Metacritic score is for only these many. These are this. So we are moving on. We clean up them. So once we do that, is NA? How many are that is NA? So 3,421 have complete information. 1,001 have incomplete information. So we are going to remove them. We are only going to work with those which have complete information, and all the incomplete information is in Metacritic. So we are going to drop where this Metacritic label is empty or not. So we are dropping them. So now we are cleaning our data now. So eliminating rows which gross data. There are certain information where gross data, gross income information for that particular movie was not available. So we are going to remove that as well. So this drop NA is going to remove all the NA columns from the rows where gross information is not provided. So we are now making use of trying to segregate or extract only the first genre, which was while we have multiple. So this is another lambda function. This is a function. This is a clever way of applying once we use it like this. And this is kind of not beginner stuff. So you can have a read on how lambda function can be done, how lambda function can be applied on. Once you apply it like this, it will be applied on each and every row within that particular table. And this is doing nothing but splitting, extracting the first component, whichever is there before the comma, and that is what is being put in genre. Rest everything will be stripped off. That rest everything will be removed. So now, after doing these operations, this is how our data set looks like. df.info or df.net, this gives us this information, and this is our head. So our name is okay. Genre, we now have only one because we have stripped many things off. Instead of 4,000 something, now we have 3,000 something number of rows because others were having null data for either Metacritic score or for gross information. We have removed them, we have dropped them. We still have to work on runtime and gross information. plus on the on having these variables or these columns into right format, that is integer. So to extract only digits, we are making use of another library which is called regular expressions, and we can create clever way of to find patterns. For example, if we are just looking for the digits, t plus will give you all the digits in this section, and it will extract you for 155 only. And there is a certain way of doing them, and that is again going to be learning regex library takes a month's time at least if you want to have a good grasp. So don't expect that you are getting everything which is written here. The motive is see the capability of Python, that how these things can be done from this. See how only simple statements are making such a complex actions happen. So we are now, once these functions are created, we'll execute it on entire table, and once that is done, now we are making the formats of the particular data, like runtime. We are typecasting into float 64. We are converting the type of the information which is there. Gross into floating point, votes into integers. This is how we are going to do that. And now look at our data, how it is looking, and probably all the steps that I thought of that needs to be there are done. Now we can see that our runtime only have 155, 104, this kind of information. There is no minutes in there. In gross, there is no M's, there is no $sign. So this data is also clean. Now we can do addition, subtraction, multiplication, division. All these operations are doable once we have got that particular format in that case. Okay. So now moving on. So our data cleanup is done. We are done with kind of the processing step. Now moving on to the exploratory data analysis. And what exploratory data analysis is? Means let's familiarize ourselves with our data. We must understand how data speak or what data is trying to convey. Means it should speak to you. It should start speaking to the person who is working on data. Okay. So now exploratory data analysis is going to help us unravel or unveil the insights that can be extracted from them. And we are going to try to address the few initial points that we had initially. Okay. So any EDA process should always be backed by questions, which is a key part. Like when you start doing any exploratory data analysis, you must have certain questions in mind, because only based on those questions, we try to answer people. If that question is not there, it's like we start trying to find anything which can be said by data. No, it is always driven by a question. It can happen that you start with one question which can lead to another question, which can further lead to another question, but it is going to be always backed by a question. You must have a starting question on which you should start digging into it. Okay. So next, let's see how our data looks like now. So we are describing the entire table. The name of the table is DF, which we have kept it right now, and DF is just nothing but I've been lazy here. We could have many meaningful names like movies, but I've kept the name of the table as DF, which is short of data frame. So DF, and now all these are the summary statistics which have been generated by simple describe command. Means the ratings, there are 3, 4, 2, 1 rows and all, and that is common with all. Now mean rating for all the movies which we have extracted is 6.5739. This much. Runtime is mean runtime is 109. There can be smaller, they can be bigger, but this is mean. Standard deviation is this much for different columns that are there, and these are different quartiles which are there, and this is the maximum and minimum. So this much information is kind of one shot. Like you hit a command and all this summary statistics is generated for you. Also, there is one interesting thing to see. When in our data, there were 6 columns in all. There were 4 columns which were kind of numeric in nature, and 2 which were kind of a string or other in non-numeric format. and see how the summary statistics are generated. They have been generated only for numeric data columns, not for other two. Okay, so once it's because once you are working with categorical variable, once you are working with numerical variables, so the different statistics or different kind of operations or summary statistics can be seen on that. For example, in when you are working with categorical, there is no sense to have mean or standard deviation in for that. You can have count, of course. You can have what are different types of values, like how many values are allowed in category. So this kind, all this information comes from the data. So this summary statistics are generated for 4 columns. Okay. So now let's start having our questions, and we try to find how it can be extracted. List top 5 movies by net collection. So there is a variable in our data set that goes by gross, and we want to look at the top 5 values. Okay, by gross income. So we see that star was, it's nothing but simple sort statement, and it will sort on the gross column. And we see that Star Wars movies, it has grossed up the maximum income. It has the maximum earning movie gross income there. Then Avatar, Jurassic Park, Avengers, and another Star Wars. So these are top 5 movies which so our firm can be easily taken away that take a conclusion that okay, action movies are doing very well. Let's make action movie. So this kind of information or extraction can be made, but we must have different angle as well. Is this statement really true? Are the means also speaking the same language? Because we are seeing the top 5, maybe it can also happen that action movies, when they are doing good, they do excellent. They are very good. They are giving you excellent revenues. But in general, is the mean value also speaking the same language? Let's have a look on those kind of things. Okay, so now let's try to group the movies by different genres. Okay, we are trying to group the movie of each genre, and we can see different statistics can be seen again. This is the different genre, like documentaries. You can see it has the best rating. If you go by average rating, it has best mean ratings. Documentary means even though they do not gross more, they gather less votes, but their rating is always high because most of the documentaries are educational in nature, and they have a very specific following for those kind of content. So this kind of conclusions can be extracted. Now, the same things happen with biography. Not everybody is interested in biography, but those who are, they realistically or religiously follow them. Okay, but these kind of movies like drama, animation, adventure, science fiction, family, so these are kind of general public movies. So you can see that votes on these movies are going to be higher. Okay, and runtime doesn't make any sense, and ratings and gross movie. And now you can see what is it? When you look at the gross mean income, family movies is way over than action movies. Means even though action movies, when they are doing very good, they are earning very heavily. But this is not true for mean. Why? Mean is much better for family. Means they, even though they are not they excel, but they are very good in general. Means maybe because they are categorized as family movies, more number of people can go and see. People like to visit theaters with their kids. So just to spend time with them, these movies can run. They are providing a better gross income. So now the organization which has given us the statement, this is a question for them. Are they are trying to make go for average but certain quantity, or they really want to make excellent movie? Then they are looking for, they can go into action. So these are different informations how we can extract from there. Now, which genre tends to attract highest rating? Okay. Now we are moving towards visualization. And for visualization, there's a library goes by the name Matplotlib, which is most common, and there is second library which is almost as popular as Matplotlib, goes by the name Seaborn. And the reason Seaborn is the reason we are making use of Seaborn, because the graphs, the charts, the color patterns are much more eye-catching when we are making use of Seaborn. And Matplotlib plots, they support only in 2 dimensions, while Seaborn supports 3D plots, more dimensional plots as well, even though we may not be using them here. Okay, so our question was, which genre tends to attract highest rating? And we have already seen that. Okay, we can see this documentaries have the highest rating. And what are these black lines? So these are the bar charts which shows that this is going to be the rating comparisons, that what is happening, and this is black lines. They are showing what is the standard deviation. How much is the standard deviation within that data for that particular group? So these are the information these plots are providing. Okay, next. Okay. So this is on the basis of gross income. Like, okay, there is no statement up there, but we can see that in x-axis we are having gross income, and in y-axis we are having genre. So this is kind of grouping on the basis of what is the income that it is, like how each genre is playing or flowing towards in terms of income or gross income. So we can see that family movies on an average is standing out most, and then comes the animation. Animation again, there is no action. Animation movies are loved by kids, and another conclusion is going to see family movies where almost everyone can go, and animation movies where kids go mostly. So it's like kids are driving the movie revenues, family is driving the movie revenues. So this can be another conclusion which can be taken from this information. So now this is another plot which most of you will identify that this is going to be a blocks plot, and the same conclusion is being shown here. The action movies, it has so many outliers. Few, see, one movie is standing out, and we have already seen that this is bound to be a Star Wars movies. Then there are few more. There are many outliers, but what is the median? What is the different quartile values? So that is limited till 200 or so, but there are many outliers. But in case of family, there are no as such outliers. Means there is nothing that is blowing out everything that has blown the revenues, but it has much better spectrum, much better in general revenue that can be provided. Okay, so moving on. So now let's try to understand how different all these 4 parameters that we were working with, how they correlate with each other. Is there any correlation within that? Means if movie has larger runtime, will it gather more votes? Or if a movie has better rating, will it have more revenue, or will it have more gross income? So these kind of correlations can be seen from this. Okay, we can see that runtime has nothing to do with gross income. Like, in fact, it is not that straightforward correlated, but this is kind of positive correlation. That gross income, whatever movies that are having good income, they gather more votes. Okay, let's visualize this. High rated movies tend to attract more votes. Was that conclusion okay? And it does seem okay. Sorry that I have to minimize it to fit everything, otherwise it would have not fit in that. Ratings are on the x-axis and votes are on the y-axis, and we can see that whatever the higher rating movies have more dots on the number of votes side. Means that is very clear-cut conclusion that we can take, that more movies having higher ratings tend to attract more number of votes. So these kind of conclusions or information can be extracted. Now this is another interesting plot which goes by the name storm plot and shows you how the distribution is happening, how it how the range of ratings are defined, and how they are clustered together. So you can see that. Okay. Yeah, moving on. Now I think only 10 minutes are left. So violent plot is another interesting plot which shows how the data is dense, how data density is. So in case of rating, you can see that for action movies, even though it has gone up till 9 or 9 something, but most of the density is around 6.5 or so. For family movies, which was standing out, has a much broader spectrum and has most density around 7.5 or something. So these kind of different visualizations which we can make use of, which we can think, we can help us understand our data and everything. See, we have this everything. This is how we can do. So this now our information is there. We can go on, present our findings to the problem giver. We can maybe this can raise either new questions, this can raise either new insights which they can make use of. Most of the time this kind of cycle happens multiple times, at least 5 times or so, where you go back and forth, present again, new questions are raised, you go back again, you present again, do the digging, do the drilling, new visualizations are created, you go back again, present. So this kind of iterations keep on happening. So data science is inherently in an iterative process. So once you are satisfied with that, then there can be a prediction problem given to you. A prediction problem can be extracted from this is, okay, we have finalized that we are going to make a family movie. Okay, now further information, right now we have limited us to say 6 or 7 columns. We can try correlating it with, okay, when we are making use of action movies, whether Ajay Devgan is going to be part of that and or Salman Khan is going to be part of that, and whether is there any correlation with action movie and any actors working there? If yes, then we will try to have, okay, to get more ratings. We have decided that it's going to be action movie. Let's take Ajay Devgan as part of that or anywhere, whoever is it going to be. Okay, so these kind of new information, so new insights are taken from. And a prediction problem can be that, okay, we have decided that we are going to make use of family movie. Can you project if we are going to release this movie in the month of September or October, what is the revenue that we can get based on certain parameters? And those parameters cannot be 4 or 5. It's going to be so many. For example, if there are, have anyone observed that most of the movies, they are released on weekends, on Fridays? Because Friday, Saturday, Sunday, they are weekends for most, and they go and spend time in theaters, and that is their most most incoming week for them. That is first week income. So similarly, the multiple things can be used as parameters. Maybe who is going to be the actors, who is going to be the actor, where is it going to be shot, what is the timing of the release of the movie, any other action movies releasing on that particular weekend. So these are the parameters can be used to gather insight whether how a movie, when is it going to be released. We can predict that, okay, maybe in the month of September, second week is going to be the best for our release of the movie. So these kind of different, but everything, so you can notice that everything is being driven by a question. So a good question raiser is very eminent or very important in the world of data science. Okay, so I think I have covered and tried to explain how a data science problem is approached from the very beginning, from the definition of the goal till insights creation. We have seen modeling is going to be very heavy in such a short duration, so it cannot be covered. But you guys, I think you guys can understand that how modeling works. Thank you. I'm ready to open for questions. If there are any, I can address. As I know that you guys are already doing the work, this job for us. Okay. Can you save the Excel created by this? Yes, we can save definitely. Can you please share this Jupyter notebook? How to create file for Spider or Jupyter and how to enter data. Okay, so these are very basic questions. Very initial beginner's blog will help you with this, how to create a file in Jupyter. But yes, Excel can be saved, can be